Hello and welcome to another session in mathematics. In this session, we'll be focusing on differentiation. And our main focus will be on constant multiplier and standard derivatives. But before that, let us take a review of our previous lesson. Welcome back. Let's start with the constant multiplier. Constant multiplier. Okay, when we talk of constant multiplier, then we're looking at one of the formulas I gave to us in our last class. It told us that when we have x raised to power n, that its differential is equal to nx raised to power n minus what? 1. Okay, we call this what? The constant multiplier. What does this connote? It means that when we have a number, let's say ax raised to power n, where a is the coefficient of x. If we have a problem like this, all we need to do is to bring down this n, which is a constant, and then multiply everything here, then raised to power minus what? 1. Okay, so that means that we'll have nax raised to power n minus 1. Do we understand? Where n is what? An integer. It may be a positive or a negative number. So for instance, if we have let's say y to be equal to 2x raised to power 5, all you need to do is to bring down the 5, open a bracket, write down your 2x raised to power 5, then subtract 1 from the power. Okay, then we'll have 5 into 2x raised to power what? 4. Is that correct? So 5 times 2 will give us what? 10x raised to power 4, which is simply what? The answer. That's how the constant multiplier works. So instead of going through the rigorous process of solving using the first principle, all you need to do is to apply what? Nx raised to power n minus 1. Just bear this in mind. It will help you solve differentiation very easily. So assuming we are given let's say 3x raised to power 7, what would this be? Our dy over dx, if y is equal to this, then our dy over dx will then be equal to 3 times 7 will give us what? 21. We'll have x raised to power what? 7 minus 1, which is 6, and that's just the answer. If we have 2x squared plus 3x squared minus 3x, what would this give us? We'll have 2 times 2 will give us 4x, 2 minus 1 will give us 1, plus this is 2 times 3, which will give us 6. Bring down our x, 2 minus 1 will give us 1. Then the coefficient of the power of x here is 1, so 1 times 3 will give us what? 3, and 1 minus 1 is what? 0. Anything raised to power 0 is 1. 1 times minus 3 will give us what? Minus 3, and this becomes the answer. Okay, then I want us to note here that the differential, if we are given y to be equal to 5, then the y over the x is equal to what? 0. The differential, the derivative of a constant, is equal to what? 0. Constants are what? Equal to 0 in differentiation. Okay, so let's then go over to what we call the standard derivatives. Standard derivatives. Okay, the standard derivatives is a table that shows us already derived problems in differentiation. Okay, so if we have y to be a function of x, then our product, the y over the x, would then be obtained. So if we have number 1, if we have x raised to power n, I told us that it's equal to what? Nx raised to power n minus 1. Is that correct? That's the first thing you need to bear in mind. Secondly, if we have a constant k, or can call it just in brackets, it's a constant. The derivative of every constant is what? 0, no matter the amount. 1 million, if you differentiate 1 million, it's just equal to what? 0. Okay, so number 3, we have exponent x e raised to the power what? x. This is also e raised to power x. It doesn't change. It doesn't change. It remains the same even when you differentiate it. If we have exponent kx, it still gives us k exponent what? Kx. This k here is what? A constant. You know that? K is a constant. So let's proceed. If we have let's say a raised to power x, a raised to power x is the same thing as a raised to power x, or you can use natural log of what? A, or you can use a raised to power x log a. Anyone you use is correct. Then if we are given log s for us to differentiate, when you differentiate log s, you have 1 over what? X. Just bear this in mind. You need this. You need this. Okay. Then let's go over to the next page to continue. We'll have number 7. And number 7, we'll have sine x. When you differentiate sine x, your answer will be what? Cos x. Okay. Then when you differentiate cos s, you have minus sine x. You see the difference? You differentiate cos sine s, you have cos s. Differentiate cos x, you have minus what? Sine x. Then when you differentiate tan x, you have what? Sec squared x. Okay, sec squared x. When you differentiate cot x, cotangent x, right? Then you have minus cosec squared x. Just note these things. They will help you in solving differentiation. When we have sec s, if you differentiate sec s, then you have sec s times tan s. Okay. Then number 12, if we differentiate cosec s, then we have our answer to be minus cosec s times cot s. Okay. Number 13, if we differentiate sine hx, we have cos s. Okay. If we differentiate cos s, we have sine hs. Okay. These are the basic derivatives you need to have in mind while solving what? Differentiation. There are about 14 of them. So I will give us one example before we call it a day. Assuming you are asked to differentiate y equal to cos x plus sine x, cos x plus sine x, what do? You just go to the table, okay, and tell us that dy over dx is equal to, when you differentiate cos s, what do you have? Cos s will give us what? Minus sine x. So you write it, minus sine x plus, when you differentiate sine x, what do you have? You have what? Cos x plus cos x. And that's just the answer. As simple as that. Okay. So if I ask to differentiate y equal to tan x, all you just need to do is to tell us that dy over dx is equal to the value of what? Tan x. And what's tan x? Tan x is what? Sec squared x. So you have sec squared x. Okay. So these are the standard derivatives of some basic functions that you need to bear in mind while solving differentiation. Thank you for joining us in today's class. To refresh your memory of what we've done, kindly provide the answer to the following questions on the screen. Welcome back. We'll call it a day here. So do wait to use the lesson note on the platform for better information on what we've just done. And feel free to leave your comment or questions on the comment section. Till we meet again, stay safe and bye.